Hey guys, welcome again to the Maths Club. If you're just joining us for the first time, welcome to our club. We've been waiting for you and we're glad you're here. If you're a returning viewer, welcome once again. In this particular video, we're looking at mensuration. And under mensuration, the first part of it under the WAEC syllabus is length and perimeter. And we're looking at Pythagoras Theorem, sine and cosine rules to find the length of parts of a triangle. If you're not subscribed to our channel, this will be a good place to subscribe to our channel and hit the notification bell so that anything that we put out, you're always the first to know. Let's get started. First thing is that for us to find the length of any part of a triangle, first need to be able to identify the parts of a right angle triangle. How do you know it's right angle triangle? Because of this guy here. When you see this box here, so it's just like when you have your x and y axis, this is 90 degrees, this is 90 degrees, this is 90 degrees, this is 90 degrees. So because there is a 90 degree inside of it, it is a right angle triangle. And the place that is opposite that right angle triangle is the triangle hypotenuse, which is the longest side in that triangle. And you see this angle theta. The place opposite this angle theta is called the opposite. And this place is called the adjacent. So this is opposite side to the angle theta and this is the adjacent side to the angle theta. So this is how we actually identify parts of a right angle triangle. And the longest part of a right angle triangle is the hypotenuse. So the length of the hypotenuse is longer than the length of this guy and this guy. That is something that you need to note. So in finding length and distances of triangles, there are three main methods. We have the Pythagoras Theorem, we have the Sine Rule, and we have the Cosine Rule. The Pythagoras Theorem states that in a right angle triangle, note that in a what? Right, if it's not a right angle triangle, it will not work. The square of the hypotenuse is equal to the sum of the square of the other two, which is the adjacent and the opposite. So we are given this, we know it's a right angle triangle because of this guy indicating that it is at 90 degrees. So it's saying that the square of the absolute value of AB, absolute value is because of these two lines. Absolute value is just like the positive value. Positive value of the length AB, the square of it is equal to the square of the length of BC, the positive value of BC, plus the square of the length AC. So this is what the Pythagoras Theorem is saying. This example brings it to home. It says triangle PQR is a right angle triangle at Q. PQ is 3a centimeter, QR is 4a centimeter. Determine PR in terms of A. Let's solve this together. So when you're given a question like this, first thing you need to know is that you have to write from Pythagoras. Don't just jump and start solving. First say it from Pythagoras Theorem. And you know that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. So the hypotenuse, why is the opposite here? Let's say this is angle theta. Opposite is 3a, so 3a squared plus the adjacent is 4a, that will be 4a all squared. So this is 9a squared plus 16a squared. So this is equal to 25a squared. So the hypotenuse squared is equal to 25a squared. So to find the hypotenuse, I have to take the square roots of both sides. So that will be square root of hypotenuse squared is equal to square root of, this will cover everything, 25a squared. Square root of hypotenuse will be hypotenuse. And we're looking at the positive value because we're told from the Pythagoras theorem that is the absolute value, which is the positive value. No, minus 5 times minus 5 will give me 25, just as 5 times 5 also give me 25. So there is also the negative value and the positive value, but here we're only dealing with the positive value. So this will be equal to 5a centimeter, right? Because square root of 25 is 5, square root of a squared is a. So our answer is 5a centimeter. Great. Sine rule. It says in a triangle, let's look at this triangle, side A, this side A, all over the opposite angle, which will be sine capital letter A, is equal to B, which is the length B, all over the sine of the angle opposite it, which is sine capital letter B, and it's also equal to C, all over the sine of the angle opposite, which is capital letter C. So let's see what I'm saying. So A over sine A is equal to B over sine B is equal to C over sine C. So if you are given two angles and one length, we can use this guy. If we are given two lengths and one angle, or to find the other angle, we can use this. So you can use each of the three methods depending on the use case. Let's see an example of this. Example 2 says that we should find x. We're given this length as 7 centimeter, opposite is 65 degrees. We are to find x, and opposite x is 80 degrees. This is a perfect example for sine rule. This is a perfect example for sine rule. Let's solve it together. So I'll come and say, using sine rule, you have to state what rule you are using. Once again, that will be x over sine 80 degrees is equal to 7 over sine 65 degrees. So if I cross multiply, that will be x times sine 65 degrees is equal to 7 times sine 80 degrees, and I'll just divide both sides by sine 65 degrees to find what's my x. So this will cancel this, so x will be equal to 7 sine 80. This is 6.894 all over sine 65. This will give me 0.906. So 6.894 divided by 0.906. This gave me x to be 7.61 to 2 decimal places. So 7.61 what? This is actually a trick. You must put the units. So 7.61 centimeter. If you don't put the centimeter, you will lose marks. So I could just write and say x is equal to 7.61 centimeter to 2 decimal places. Always take note of the units of measurements. Great. So cosine rule. To find the length of side A using cosine rule, what do we say? We just say a squared is equal to b squared plus c squared minus 2bc cos a. So this is good when you have two sides and one angle, right? You have two sides and one angle. So you can see different cases and different applications. So if I have two sides and one angle, cosine rule comes in very, very well to solve that particular question. So a squared is equal to, it's just similar to Pythagoras a little bit, but there's a difference. So a squared will be equal to b squared plus c squared. Here we're now subtracting 2bc cos a. Let's see an example. Example 3 says that we should find x. We have two sides and one angle. Perfect example for a cosine rule. Let's solve it together. So to solve this, I'll say using cosine rule, which states that a squared is equal to b squared plus c squared minus 2bc cos a. Always write the equation. So I will just say my a here is x squared. So x squared is equal to 22 squared plus 28 squared minus 2 times 22 times 28 times cos 97 degrees. So I'm tempted to do everything at one stretch, but let me just break it down. So 22 squared would give me 484 plus 28 squared would give me 784 minus, I'll do all of this together. So that will be 2 times 22 times 28 times cos 97 degrees. That will give you minus 150.143. Okay, let me just simplify first. So that will be 484 plus 784 minus as minus is plus, so plus 150.143. So plus 784 plus 150.143. That gave me my x squared to be equal to 1418.143. So if I take square roots of both sides, that will be square root of x squared is equal to square root of 1418.143. Square root of x squared is x. Of course, it's a length, so I'm dealing with only the positive value. So square root of 1418.143, that will give me 37.66 centimeter to 2 decimal places. So these are you solve questions like this. If you are given two sides and one angle and you're told to find the length of the last side of a triangle. So this one did it to 3 significant figures. If you did that, you still get the same answer. So with this, we've come to the end of finding the length of sides of a triangle. We've used 3 methods: Pythagoras, sine rule, and cosine rule, and we've told you the application of each of these points. Pythagoras theorem, if it's a right angled triangle and you're given two sides, which would be hypotenuse squared is equal to adjacent squared plus opposite squared. Sine rule, if you are given one side and two angles and you're told to find the length corresponding to the opposite of one of those angles, it just be A over sine A is equal to B over sine B, where A and B, capital letter A and B are angles and small letter A and B are lengths. And if you are given one angle and two lengths, and I also find the length of the last part, that's where cosine rule comes in easily. If I've watched this video up to this end and you've not liked the video, you've not subscribed to our channel, or you have a question and you're not asking this in the comment section, please do so right now. I'll see you guys in the next video. Bye for now.